Here I am taking one op-amp block. Okay. This is a sample schematic for an op-amp operational amplifier. Okay. This is a general schematic. Okay. How the schematic will be looks like. That is the thing here. Here, all the gates. This is one device, which is current mirror diode device. Here, gate and drain are shorted together. Is it my screen is clearly visible, ma?
Yes, sir.
Yeah. Here, these terminals are, one is bulk, which is connected to supply, and supply is shorted together, and gate and drain are shorted together. Here becomes single terminal. Okay, this will become single terminal, and this will become one single terminal. By this connection, it will become like a diode connected device, where we are telling that in current mirror we will have one diode connected master device, where the current is going to copy for the common gate connected devices. Okay, here this gate is connected to commonly to another supporting gate. We can simply draw one straight line and we can connect it directly, ma. Okay, in order to make you understand, from one point I have connected these things. Okay, this is one diode connected device, and this is the slave device or child device, which is here. We are copying current from this diode connected device to the slave device 1, slave device 2, and this is a dummy. This is a dummy, ma. Okay, here the which is last one. Here I have taken one dummy. How you are defining that this is dummy?
Sir, everything is connected to VDD, sir.
Yes, all the nets are connected to VDD, same VDD. Okay, supply. It is a full dummy. It is a full dummy. Okay, here, and downside we have dip pair. This is one input and this is another input. Input A and input B. I am considering Vn plus and Vn minus like that. Just I have given an in order to make you understand input A and input B. Input A and input B, which gives two different inputs which are in opposite potential, and devices wise we have same quantity of multipliers and fingers. Okay, and it is connected with a common net, one common net, and others will be connected towards the current mirror. Other two nets are coming from the current mirror block. Okay, this net and this net are coming from the current mirror block. Okay, where these two devices will compare the signals with same number of routing, same length of routing, and commonly compares and gives you the output here. Okay, where you will get the output as Y. And before going to process with respect to Y, we will have one NMOS tail filter. We will have one NMOS tail filter, where the gate is given as a bias connection, where the gate is given as a I bias reference current. Okay. Now what about this device? And what about this device?
Sir, half dummy, sir.
Yes, half dummies or signal dummies. Have we discussed, Karthik, this thing? No, na?
No, sir, but you told us, sir, what is half dummy and full dummy, sir.
Okay. No, why I am thinking is, if I have already explained, I will go to another one. So fine, no worries. Good, great. Thank you. Thanks for the remembrance. Okay, this one is half dummy or signal dummy, which is going to share with this net commonly. Okay, and one side signal is coming means that will be connected to the signal dummy. Okay, why we need these dummy devices? These dummies are used to protect the active devices, not to have effect on the active polygates. We are adding these dummy devices. In general, in FinFET and all, we use stack dummies. Stack dummies. There will be stack dummies, series stack dummies will be there. How the series stack dummies means? Just I am editing this one for your reference purpose. Copy. This is one terminal nama. Okay. Here this is having one device with two multipliers. Okay, we need to have single multiplier only. Q it and make it single multiplier. Single multiplier device. Okay. Single multiplier device. Okay. Here if I want to make a series dummy or series stack dummy, just copy this one. Here you see, there is no intermediate connection in between these two, but we will give common like this. Here this gate, this will be connected to one separate net. Okay, this side will be connected to one separate net. Okay, and there will be no intermediate connection in between. These terminals will not be connected to anywhere. Okay, and finally this net. Okay, and these three gate nets will be connected to supply connection. Where we are going to connect, we are going to connect supply connection, VDDQ. If it is a PMOS, it will be connected to VSS. If it is an NMOS, it will be connected to, if it is a PMOS, it will be connected to VDD. If it is an NMOS, it will be connected to, Karthik, is it my voice is audible?
Yes, sir.
Where we will connect for NMOS?
Sir,
For NMOS bulk, where we will connect, man?
Sir, VSS, sir.
Same. Why you are confusing that? Okay. Okay, like this the device will be. Okay, this will be VSS and this will be one common net. This is nothing but stack devices. 3 series stack device commonly they will use for the proposed system, and more than wherever there is requirement is more, they will be based on that, they will be increasing depending upon the volume of area. Okay, The minimum requirement will be 3. Clear? I am deleting this one. Ma. Here, when we observe, this is a diode connected device and these two are slave devices. The diode connected device should be always protective. So what we will try to plan means we will make it in a center. We will try to make it in the center as per the floor plan. Okay. So obviously we will consider, right now we are considering 2 multipliers. Okay. If there is a single multiplier, what we need to do means we need to add dummies on both sides and we need to take out the connection with respect to neighboring nets. Okay. So instead of that one, what we are doing, we are making 2 multiplier. Commonly we will see 2 multiplier device only, diode connected device. 2 or 4 like that, even numbers will be there. Okay. And this will be even numbers, same. 4 multipliers. Here I am taking 4 multipliers. If it is 1 ampere, it will be 2 amperes. Okay. And I have considered here 4 means again 2 ampere. This device will pull 2 ampere. This device will pull 2 amperes. Okay. Means mirroring from copying from this current mirror diode to neighboring devices. That is the op-amp current mirror logic. Is it clear? Everyone, is it clear?
Sir, can you repeat this?
Yeah, okay. Fine. In an op-amp, operational amplifier generally consists of 3 components, major components. Okay. One is current mirror block. Okay. Another one is dip pair. The center one is dip pair. Dotted lines is not visible here. Okay. Fine. These two are dip pair. Okay. And this will be NMOS tail filter. First set will be current mirror. 1, 2, 3. Where the gates are commonly connected together, supplies are connected to VDD, and drain and gate are connected for this diode connected device, and other gates are connected to the same net, and here these two drains are shorted together and take as an input here for this network device, and this drain is connected to this as an input supply, and this is a diode connected device. Consider this one like we can make like one. Already I have shared one current mirror logic for you people, PPT. One photograph also I have shown, I hope so. Karthik?
Yes, sir.
Okay, fine. Do you people remember regarding that current mirror logic saying? Okay, I will show you now, or else Karthik. One minute. Yeah. Yeah, here we have shown this one, current mirror logic I have shared you. What is a current mirror? In the current mirror, I said that we will be having gate and drain are connected, shorted together and forming one single terminal. So based on that, as per the saturation current equation, normally the current equation is equal to I is equal to half mu n Cox W by L into VDS minus VT whole square. Okay, this will be the formula for normal current equation, whereas the drain and gate are shorted together. Drain and gate are shorted together. So VDS will be same as VGS will be same as Vt. The operating voltage is equal to Vt should be equal to VGS. So based on that, when there is to be in a saturation region, VDS should be less than or greater than or equal to 4.5 volts. Here VDS is equal to VGS is equal to 5 volts. If there is a decrement, there is a power is getting lower, at that time it will drag the current from the top. So it will always satisfy the condition, whereas VGS minus VT is greater than or equal to VDS. Means voltage applied across gate and source terminal will be always greater than drain and source voltage, whereas gate and drain are shorted together. So in order to make that one, voltage equation V1 is equal to root over 2I. Means this formula was just reversed. This current equation was reversed here. Okay. And VT is nothing but threshold voltage what we are applying. Threshold voltage. Here when we are connecting one more device here. This is a common current mirror device. In current mirror device, this I1 is a source which is connected to drain terminal and source terminal of a MOSFET. This is M1. M1 is a device which is connected operating with a voltage of V1. So in order to get the V1 voltage, what was the current equation? We are getting the current equation. From the current equation, we are calculating that V1 here. Okay, I1 is equal to half mu n Cox W by L. Na? Same thing we are reversing to get the value of V1. Okay, V1 is equal to, here we have square. So it become root over. Here we have minus V1 minus Vt. So here it become plus. Okay, here it become root over. Here we have 1 by 2. Here it will become 2 into I by mu n Cox W by L. Okay, this is the formula. So after this getting the V1 value, voltage value, when we are applying, when we are adding one more device here, I said we are having common gate connected devices with respect to diode connected device. Common, this is a common gate which is connected to another device, slave device. So in order to get this I output current, how to calculate means what we will do, I output current is equal to same formula, half mu n Cox W by L, device width by length into V1. What was the voltage we are applying here? V1 minus Vt whole square. Whereas V1, what we are getting from this equation, V1 value is this one. So we are submitting this V1 value here. So after submitting this V1 value, we are cancelling V1. Here we are having plus Vt. Here we are minusing this Vt. Means in this formula we are submitting V1 instead of V1 value, we are submitting that value here. So all will be getting cancelled, and this W by L of second device divided by W by L of first device into I1 current. Whatever the current we are applying, based on the width and the length of the device, the current will be getting multiplied. Okay, this is the current mirror multiplication application. Getting, sir? Is it clear? Already we have discussed this one. Karthik, Shiva, Rangaragaru, are you there, sir, in the last class when we are discussing this topic?
Yes, sir.
Okay. Is it clear now?
Yes, sir.
Regarding current mirror?
Yes, sir.
Can we, Ruchita, is it fine, ma?
Yes, sir.
Okay, fine. Here the thing is simple, ma. Here we have I1 is the current which we are applying 1 microampere. So you need to I output as 2 microampere. So what you will do in order to get the 2 microampere, what we need to do, ma? W by L into L of 2 by divided by W by L of 1 is equal to reference current. This is the current formula for the output current. What we want is 2 microampere we need. So in order to get that, what we need to do, we need to increase the width of the transistor, double the width of M2 transistor width. So here in this layout, what we are doing, we are this is having 2 multiplier. Here it is 4 multiplier. 4 multiplier means it is having twice the value, correct? Ma, is it correct?
Yes.
Is it fine?
Yes, sir.
Yeah. So based on the it is hanged up, man. So based on that value, based on that logic, we are incrementing the multiplier. If we want more currents to drag up, so we are adding multipliers. Okay, increasing multipliers. This is 2, this is 4, this is 4. Okay, 2 devices will be pulling 2 ampere more. This is 1 ampere means this will be pulling 2 ampere current. Normally it will be very less, ma. For one device will carry very less current. Okay, just I am telling one example. Okay, fine, clear.
Yes, sir. Got it, sir.
Yeah, this is for current mirror. Now when we are going for dip pair, differential amplifier. Differential amplifier is a circuit which compares the two differential inputs. Here we are having one input A, another input B. It will compare the two input values and it will give one resulted variable wherever the variation is there. Means our required output, desired output will be given as Y. Okay. What is an op amp purpose? Op amp purpose will be for amplification. Correct? There, whenever there is a variation in these two signals, that variations will be compiled, and based on that, after compilation, it will give one specified required frequency. Okay, required thing. So that again will be filtered through NMOS tail filter, where we have I bias as a reference current. Based on that current, this device will act and this will filter out, or else it will pass the supply to Y. Okay, this is an op amp thing. Clear? Okay. I am not saving. I have not saved that one, ma, because I have edited that one now. Okay. Right now, I am opening the layout view. Here, normally analog blocks won't have much height constraints. Analog blocks will not have much height constraints. Getting clear? So, but we need to follow the minimum TRCs and we need to make the cells. Okay. Here, I have created one current mirror in the top and dip pair in the here and one NMOS tail filter here. The floor plan is like this. Current mirror is all top. Dip pair is in one set. Tail filter is also is in same set. Why I have made a separate guard ring?
Because NMOS and PMOS devices are also two different.
Yeah. And I don't want any noise to enter into this current mirror and dip pair. Okay. So that is the reason I made it in a different quadrant. Okay. Noise, and in order to avoid latch up conditions, I followed this guard ring structure. Clear? Now, again, how I have made the cell matching here. Matching. We need to follow the matching techniques in current mirror and op-amp, correct? Sorry. In op-amp, we need to follow matching technique for current mirror and dip pair. When you see this one, just a minute, ma. Here, when I fit it here, you see, here this is a diode connected device. Diode connected device where I have placed in the center. 2 multiplier device. So 2 polys will come. I have shared common drain. I have taken a inside terminal as common drain. Inside terminal as common drain. Why? If I am taking source as common inside, so I can't merge with respect to neighboring devices, because neighboring device commonly connected with source only, not with any other net. This is a current mirror diode connected device, means we will have only 2 terminals. One will be source, another drain and gate will be shorted together. Getting ma? Clear? So in order to make that one, I have placed a diode connected device in the center, and this will be 2 sides I am flipping, means I am splitting 2 devices one side, 2 devices one side. Interdistized ma. Okay. And second one, this third device. 2 more devices this side, 2 more devices this side. Okay. And finally, to protect these active devices, I have placed the dummy in the corner. One dummy in this side, one dummy in this side. Clear? Is it fine? I'm not getting any response from your
Yes,
end.
sir. Sir, can you maximize it, sir?
Which one? This one, huh?
Yes, sir.
Okay, good, great.
Sir,
Okay.
here, sir, if you come, sir, here, the screen, sir, it will maximize the whole.
Sorry.
Sir, if you come in the middle of the screen upside, sir, there is an option to.
Where?
Sir, near, sir, this word blue, sir, up, sir, blue.
This one, huh?
No, sir. So up, sir.
Yes, this one, huh?
Near, sir, in the middle, sir. If you go and in the middle of your screen, upside, sir. If you go and yes,
Okay.
sir, this one,
This
up,
one,
up, sir, up, sir, up. This will come down, sir. This, yes, this, sir, yes, sir.
Okay. Is it visible?
No, sir.
Not visible, huh?
You have to zoom, sir.
Is it fine now? Which one you are asking, Karthik? Karthik, is it my screen is visible?
Yes, sir. Yes, sir.
Okay. Which one you are thinking? This is a God ring, ma. Okay.
No, sir. I am checking, sir. How did you do matching, sir? That's it, sir. Matching.
Okay. You want matching.
Yes, sir.
Karthik, we have discussed regarding interdistization and common centroid and cross-coupled common centroid, correct?
Yes, yes, sir.
Here, I have placed 2 diode connected devices in the center. Okay. Which are
Okay, sir.
commonly sharing with respect to one drain net. Okay, this is the dry net. If you want me to label, I will label it for you.
No, sir. It's a drain. I understand, sir. Drain. Drain is in the
Okay.
middle, sir.
Center is the drain. Okay, this one was a source VDD, which is same sharing with neighboring B item, item B. Okay, and internal net will be different, and there is one more multiplier that is connected with same BSS VDD. Okay, here what I will do, I will connect it for you. See. Where is this going on? I have made always on top. Okay, I have right clicked here and made on top. Getting okay. So the schematic will be and it will be on top until I minimize. Okay, just I am showing you this is a diode connected device. Okay, where this is drain point and sources are here. Just a minute. Okay, copy, and this is also supply. Fine, and
Yes.
this is supply. So these two are supplies, and this is commonly connected with another device. What was that device? This is that device commonly connected with supply. Okay, and this internal net, this is the internal net. When you see this one, this is the internal net which is getting highlighted, getting green color one. Okay, this net is internally means by averting two multipliers, I took this net inside. Okay, and one more, this terminal is also source. This terminal is also supply. Okay, and this one is also supply. Same like alternate manner. Making layout is one thing and understanding and making is different. Okay, you should learn and you need to make that one. Here you see, this one is your dummy device. Okay, where the drain is in the center. Okay, drain which needs to be connected with gates. Okay, and there afterwards I have placed two neighboring devices which is commonly sharing with supply. Okay, two multipliers this side, two multipliers this side. Okay, and next one again I have placed third device. Third device on alternative way. Same, commonly sharing with supply. Okay, and finally I need, this is half dummy. We need to place this one with half dummy, but I made it here full dummy. But commonly it will be coming with full half dummy. Why? Because this net is ending with supply net. Sorry. This device net is ending with supply drain. This is commonly shared with a drain. Okay, drain. Okay. Then this will be supply. Then again, okay, commonly aborted with respect to same net. Okay, fine, correct. If you probe this one, I am pressing 9 ma. Okay, in order to probe this one, I am pressing 9. Okay, and I am probing this one with again selecting this net 9. Okay, 2 nets are need to be highlighted. See here, ZAG connection. This to this, this to this, this to this, this to this. Cross coupled common centroid we need to make na. Like this we are going to make. Downside, can I explain for, is it clear for the current mirror?
Yes, sir.
Rangarav, or is it fine, sir?
Yes, sir.
And you take one example of this one, okay? I have shared one photograph with you people. I will share this one also. Karthik, I will share my credentials with you. You make this one and share to group, share in group. Fine?
Sir,
Okay.
is it okay for you to share the path?
Fine. That's what I am telling. It is mine. For me, they have given one thing. Okay,
Yeah.
I will share.
We can add this library to our.
Add path.
Yeah.
It will be add. It will be giving.
Yes, sir. In the library manager.
Right click and show
Yeah,
path
right.
and that and all you are giving.
Yeah. Directly Bharat library only you can give, sir. Right click on the Bharat library.
Okay, fine, great.
Property. Properties.
Okay.
Yeah. You can share read or write path.
Okay.
Anything is fine, sir.
It is not selectable, ma. So
We
that's why
have
I'm
to
checking.
we have to drag and select, I think. Yeah.
Okay. Copy. Just I am copying this one. Okay, somewhere in the WhatsApp group I will test. That's
Yeah.
fine.
Yes, sir.
Just a minute, one. I need to do this thing also. Where it went? In the subject group, I am sharing my path. Okay. Is it shareable? It is not pasting my here.
Sir, can you paste on the terminal first? I think.
At least on Notepad it should paste.
No, sir. Terminal inside VNC.
Inside VNC. Okay. Okay. This. Okay, ma. Copy.
Sir,
Paste.
can
It
you,
is not taking. Ma. Okay, what I will do, I will take a screenshot and I will share. Fine, that's fine.
Yes, sir. That will also work.
Okay. 1 minute. Give me a minute. Yeah, I have pasted that one, ma. Okay, please check it and type it from your end. Okay, maybe it will. Karthik, is it fine? Fine for everyone? Ma, here, this is a current mirror thing. Now, we need to go for cross-coupled common centroid. So, in order to make that cross-coupled common centroid, what we have done is, this is one device, correct? How the pattern is like, it was in the group, ma. Okay, I will make it ungroup first. Ma, you know, transparent group, na? You know, it was in the group, okay? It was created in the group. So, if you want to select that one, this is a group option. Normally, we select the devices, and if we click it, it will become like a group. Okay, if it is already in group, so in order to edit that one, we need to select that one and press this transparent group. Okay, when it is in clone, there will be transparent clone option will also be there. So that also need to be known. Okay, and one more thing, if we go and if we make it transparent group, then the devices inside that group will be selectable. Clear? Or else it will select like complete one. Now I am deselecting this one just to see. When I am selecting, it was selecting complete devices because already it was in group. So it will select the entire group. It will not select one device. So in order to make that individual devices selectable, we click on transparent group and just click on that particular device which you want to select. Okay. A, this is a pattern. A, B, B, A, and means 4 A's in the one row, 4 row A's in the another row. Okay, total 8 multipliers. 4 B's in one row and 4 B's in one row. It is in the pattern of A, small, sorry, A, B, B, A, B, B, A, and this corner device are dummies. Okay, this device and this device and this device and this device are dummies, which I have added for additional safety purpose. Okay, these corner devices are dummies, and here also for NMAS also I have added 2 dummies. Okay, in the corners I have added 2 dummies, but this is a single device, so we can make a continuous flow, continuous devices. Okay, clear? The pattern of the device is like dummy A, BB, AA, BB, A, and downside it will start with B, dummy device, then B, AA, then BB, then AA, then B. Okay, like that the pattern is. Is it clear?
Sir, in the place of full dummy, can we use half dummy, sir? In both front
That's what.
mirror.
When we use half dummy means when we are getting signal at the corner. If this is a common net, okay, this is one device, ma. Okay, if I am making this connection, if I am placing single device here, just see, this is a single device. Sorry, this is a single device, ma, A device. So in the A device, commonly I have what I will be having one source and one drain, correct? One single device, I will be having one source and one drain, correct?
Yes, sir.
Then source is, drain is, I have shorted this net common. Okay, this is a common net, but I don't have common net for outside position. This is a signal net. This is coming outside, pink color one. Getting? This is one other side of that A device. So it is coming outside. So in order to protect that signal, I have added half signal dummy.
Okay, sir. Sir, if either of the one, like either source or drain, is not connected to a common connection, then we can.
No. Why you need to think in the way like whenever we are getting any signal in the outside corner, we always try to avoid signals coming in the corner. Okay, if signals are coming in the outside, means outer corners of the devices boundary. So in order to protect that that devices, we will use half dummies or signal dummies. The name for this dummy is signal dummy or half dummy. Okay.
Oh, okay, sir.
When we are getting outside corners supply connection, that area we call that device as full dummy. Full dummy or full supply dummy we will call. Formally, sometimes the people will ask you to make a full signal dummy, but full some signal dummies will create more leakages within the device fabrication. So my internal team suggested me never ever use in the layout full signal dummies in the corner. Try to use either stack dummies. That is one more chance option they have given. Means I don't know. Means fab thing. Different fabs will have different things, man. When I comes with we won't have dummy concept in 3 nanometer FinFET technology. FinFETs we will be using filler cells.
Yes, sir.
You won't be using dummy devices. If we use dummy devices, we need to add in the schematic, na. So
Yes,
in
sir.
order to avoid that thing, we use filler things. Filler is a dummy like devices where they will be having continuous ported devices. Okay.
Sir, means here we can't use stack dummy, sir.
Here we can use but the thing is, this much area we can. But this is for practical purpose, temporary purpose only we are given. When if we want more stack dummy means what? As I said that all
multiple
these
and multiple.
single devices will be using. Internal nets will not be connecting anywhere, and only this one corner net and one bottom net will be connected to that devices. That's it.
Okay, sir.
That is the reason why we use stack dummies in the corner for this device protection. Okay. Series stack dummies in the device protection. Just I made one simple dummy device in the corner to make it in easy understandable. If you are making in series stack dummies, again you will ask that the question, sir, the internal net is floating. So it is just we have touched it. So we need to anywhere we need to connect. No need of connection. That is internal just flow from top to bottom series. There is a break. That's it. Okay.
Okay, sir.
And that too, this is if we don't have dummy podes. So if we have dummy podes, we can understand easily. We don't have dummy pode, na? So it will be a problem. If without dummy pode, if we are creating the cells, na, then what happens? You can't justify A document or B document. Sorry, A device or B device. Which is active dummy, which is active poly, and which is normal poly, we can't understand. Na? Here there is no separate layer, I hope so. Clear?
Yes, sir.
Is it fine? Fine
Yes,
going?
sir. Yes, sir.
Any other doubts?
Sir,
Team?
I didn't understand the dummy port thing, sir.
Dummy port. Here there is no dummy port, ma. Actually, there will be one separate layer for like dummy port layer. In FinFET technology, I have shown you dummy
Yes,
port
sir.
layer.
Yes, sir.
Port dummy layer. That will be one separate layer which will be drawn over polygate.
Yes, sir.
Okay. We are not using it here, ma. Okay.
Okay, sir.
Ma, anything else? Shiva, is it fine? Clear? Are you there?
Yes, sir.
Yeah.
Clear, sir. Clear.
Okay. Yeah. Ma, this is one op-amp block. If you are done with that things, you can come up with this one, ma. I need full connections and all. Okay. I need the full setup. And when we will have the review, sir, regarding that your blocks, up to NAND and NOR, we have seen already, I hope so. Almost all, I suggested some things for Shiva, Rangaragaru, you made it, sir, from your
Sir,
end.
yes, sir.
The corrections wise, you made it.
Yes, sir. I didn't label, sir, but the other things I did.
Okay, fine. Shiva, have you done, ma? Have you followed that one? You don't have time.
Sir,
I am asking that the corrections
sir,
I have
I'm
made for you for the standard cells, na? Have you followed that one?
yes, sir. I done, sir. I done that in standard cells. I thought you are asking that 2x, 3x.
No, not that one. If it is fine, one by one we will go on, ma. Okay. And you
Okay,
need to be little faster. And I don't want to always ask you the question that you have done or not. Okay. I want you follow up continuously and make it clear. Okay. Okay. Then, about others. Karthik,
Yes, sir.
sir, yes, sir. What happened, sir?
Sir, done, sir. I'm done with all the standard gate cells.
All the cells are done. Sir, once reviewing, if you find anything mistake, na, you have to do 10 times. Repeat copy.
I will check again.
Okay then. Okay, fine. Ruchita, what about your cells, ma? Have you followed that instructions which was
Yes, sir.
given?
Yeah.
Okay, great, ma. Good. Okay, and this is the thing. And for this op-amp block, just I am closing this one also. And level shifter you already made. I hope you have clean. Inverter 2x you have asked for question. And this is the open read only. Ma, inverter 2x means I made with 2 polys here. Okay. By considering 4 fingers, I have made this one. Okay. Instead of single finger, I made 4 fingers. 2 fingers with one device is there. I made it 4 finger device. Okay, that is fine. Op amp is okay. Op amp 2 also made a op amp 1. Okay, we'll see. Basic. And once this op amp 1 is done, we need to go for op amp 2. Means 2 level. This is a single level op amp. In 2 level op amp, we will have 2 current mirrors. That's it. That is a simple change. Okay. And we need to go with the comparator block. I have shared you the pic in previously. Yeah, this is a comparator block. We will see. Obviously, we will explain this one. We will see with the time and all. Any other questions? Anything to ask? Any add-ons?
Sir, can you explain the matching again, sir, tomorrow? if possible, sir.
Okay, then. Okay,
Sir,
fine.
yes,
We
sir.
will discuss. Sorry.
Yes, sir. Yes, sir. Same question.
Same question. Who, sir? Another one.
Sir, me.
Yeah, Ranga. Fine. Okay. We will discuss on tomorrow regarding matching. Okay. Again, we will discuss. Fine, ma?
Yes,
Right
Okay,
sir.
then. Okay. Bye. We will catch up tomorrow, ma. Okay. Most probably same time. If there is any change, I will inform. Okay.
Okay, sir.
Okay, sir.
Okay.
Yes, sir.
Right. Bye. Bye. Bye.
Thank you,
Bye.
sir.
Thank you.